Best practices keep your code clean, safe, and easily understood by other developers. In this video, we'll dive into the best practices for the smart contract framework, Foundry. So let's begin. Now, if you do not have a project set up already, please follow the instructions on screen now on how to do that. And if you do, I'll be using the basic default settings, so we have a counter.sol and a test file for that counter.sol. Now the first thing I want to say is that all formatting should be done using the forge format command. So for example, if I have indentation here, right, just simply run forge format and then it will reformat that indentation and keep everything consistent. In your test files, you want to use named import, so that means explicit importing. There's two ways to import: named imports or importing the entire file. Now, for the Forge standard library, you do want to import everything. For everything else, however, you want to use named imports and be explicit. The reason why is because you might get some code editor or sulk errors when it comes to definitions being used multiple times. In our situation here, we have import counter, which is a very simple contract. But if we had different definitions or different contracts or different parts of this file that we did not want to include in the test file, then you would use a named import like this. If you're importing from other directories, such as the test or scripts folders, you want to do it in this order. So you will have Forge standard first, followed by test imports, and then script imports, and finally any imports from the source directory. As you can see, we are using relative imports here, which is fine for smaller projects, but when it gets larger, you definitely want to resort to absolute pathing. So simply, instead of doing this syntax, you just say source and then counter.sol. Relative pathing may help your code editor figure out how to do auto completions and linting. However, absolute pathing helps a lot, especially when it comes to large projects and when files are being moved around quite a lot. It makes it easier to track where they're coming from and how they're being imported. All testing files should follow this syntax of name.t.sol to indicate that it's a test file. Always use early returns in your logic. What do I mean by this? Let's say we have a function here called decrement, right? Exactly like this. And we don't want the count to go below 0. We'd simply add in a require statement like this that will early exit. So imagine there's more logic in between these two lines of code here. You would always want to return as early as possible. Another best practice is keeping related logic close together. Again, this is a case of, let's say we have a function of balances, right? Balances that simply returns the current balance of a given address. In this case, it wouldn't make sense to whack it in between increment and decrement because they're just unrelated. So you'd most likely put this at the end, right? And again, this is where forge format comes in. So forge format, and there we go. Regarding unit test, never make assertions in the setup function itself. Instead, have a dedicated test called test setup that simply executes the setup function and then does an assertion within the test itself. There's two ways to organize your unit test. One is like I've shown now, where you have one test contract that executes every single method on the smart contract itself, which is preferred. Or you can make a different test contract for each individual method on the contract itself. So in your test file, you would have contract increment is test, and then you would only test the increment function and all the edge cases for that function. Your test should be written in the same order as the original contract itself. We have a set number and increment. So in our test, they should follow set number and increment, but here it's the wrong way around. So we'd have to do it like this. And again, let's run forward format, and there we go. In Foundry, you can use helper contracts to abstract away functionality that you do not want to include within the contract test itself. So for example, you could have another file here called counter helper.t.sol, which would be another contract. Counter helper is test, right? And then you want to import from Forge standard. Again, this helper contract could have fixtures, helpers, any variables that you want to declare here that you want to use within the test itself that you don't want to define here. It really just keeps it a lot cleaner and a lot leaner. So you want to import here, and then instead of doing this, you could do import counter helper from. So now we're importing directly from the helper file, and we no longer need this anymore because we instead use counter helper, and now it's more explicit as to what we are doing in this test file. Integration tests should also follow the same syntax. So in your test folder, you would have maybe another folder in here called integration, and then you would have the syntax of counter.integration.t.sol. There are different naming conventions for different kinds of unit tests. So for the standard test that you just saw then, you would have function, test, and then description, name, which in our case was like setup function or increment. So that would be a standard test. For fuzz testing, you want to do function, test, fuzz, and then the same description name. For functions, we're expecting a reversion to occur, so you're expecting the count to not go below 0 and instead say, no, it can't go below 0. You want to do function test underscore reverts, followed by an if or when condition here, and then the condition itself. So in our scenario, we'll have something like if underscore count is negative. For tests that fork from a different network, so maybe mainnet or some sort of testnet, you want to use the syntax function test. Now to combine all of them, you'll want to do something like function test fuzz fork underscore if and then condition. This last test is saying test a fork of a network using the fuzzing technique, so different parameters that will try and find edge cases in your logic, and then do an if to expect some kind of revert. That's all for now, but check out my previous video where I break down unit testing for an NFT contract, where best practices play a very big role. Thank you for watching, and I'll see you soon.